Hey friends, it's Anton here and you're on the Blackroom channel. We're in our new showroom. And in this video, I'll tell you about strategies for placing different types of acoustic panels in a home cinema and theater. You've been asking me about this topic for a long time. Actually, we've talked about acoustic panels and acoustic design quite a bit, and I thought this topic was already covered. But in the comments, you kept insisting that we make a separate video dedicated to the topic of acoustic design in theaters. So today we're filming it for you. Let's start. So, a brief look into history. Why do we even need acoustic panels? Inside the home theater, we need them to create the right acoustic atmosphere inside this space, so we don't have various wanted effects like flutter echo. So when we clap our hands, it shouldn't sound like this right now. We're about 90% done with the acoustic design here, so that effect is still present. But once the absorbing panels take their place on the ceiling right here in the front, that effect will go away. And a carpet will also be placed right here. In front of the screen, acoustic panels also help to bring the sound reverberation time in this specific room down to the required standards, meaning they reduce it. By the way, we have a whole separate episode on reverberation time on our channel. If you haven't seen that video, make sure to click the link in the description and check it out. The next task that acoustic panels, specifically diffusers, solve is creating a virtual space, an additional virtual volume that isn't actually present in the original room you have. The essence of having a small home theater is that we're trying to recreate the scale of sound, like what we hear in an IMAX. And it's the diffusers that help us partially solve this problem. Now let's move on to the strategy itself, where to place which type of acoustic panels, and most importantly, how many. Let's start with the screen wall. The screen wall in a home theater, if done correctly, is always like this one we have in the showroom, a kind of baffle wall, or roughly speaking, a flush-mounted structure where all the speakers, acoustic systems, and subwoofers are built in. The remaining gaps and spaces are treated with sound-absorbing material in one way or another. Here we've taken it a step further, going to the extreme, and we've filled the entire inner surface of this structure, which is about 33 centimeters thick, with sound-absorbing material. This is necessary, roughly speaking, so that the screen wall doesn't interfere with the front main acoustic systems. So, the absorption on the screen wall, which is around all the speakers, completely eliminates any diffraction that can spread out from each acoustic system in any direction. It's also really useful for killing the first reflections and all the reflections from other acoustic systems, and we keep adding more and more of them every year. Here we have Dolby Atmos with 15 speakers, so if we subtract 3 from 15, we have 12 left. A whole 12 channels back there can play, and that sound can hit the screen wall. We don't want to hear that rear sound from the screen wall, so the right solution here is to make everything as sound absorbing as possible. Now let's move on to the walls. The walls, especially the first reflection points of sound, the direct sound from your front acoustic systems, are, as Americans say, crucial, meaning they're vital. And how you treat them will affect the quality of both the stereo panorama and the images you see on the screen. Yes, the sound images that will blend with what you see on the screen. Overall, this is a very important thing. Starting from the 1970s, there was a trend to eliminate those very first reflections. But then a Canadian team of psychoacousticians led by Dr. Floyd Toole conducted a whole bunch of research and actually proved that the first reflections are actually more beneficial and add to the sound its airiness and its scale, rather than just eliminating those first reflections from your walls. So, in the first reflection points, we usually use a combination of what's called 2D diffusers. Here you can see the cylindrical panel. So it diffuses in two-dimensional space. Right here, just like that. The sound comes in and it reflects off of it in two-dimensional space. In this case, it kind of slices the sound and spreads it throughout the room, evenly, as much as possible, taking into account what frequency it can diffuse. The thicker this cylinder, or rather the half cylinder is, the wider the range of frequencies it will work with. Ideally, it should be about 15 centimeters. However, unfortunately, it's not always possible to place such deep acoustic panels in a private home space, especially when we're talking about rooms that are about 20-30 square meters in concrete. However, as you can see on the right wall of our showroom, we not only have cylindrical 2D diffusers, but there's also an absorbing panel, purely sound absorbing. This is used to create a combination of diffusing and absorbing surfaces so that we can effectively get rid of the flutter echo. If we just place these cylindrical, polycylindrical diffusers here, there's a chance that the flutter echo between these two walls will still remain to some extent. That's why a checkerboard pattern of alternating diffusing and absorbing panels is used. And basically, this rule of alternating panel types works in other areas of the room as well. We'll walk around and I'll definitely show you. But look here, there's an important detail. Let's move to that wall now. Here, as you can see, we have absorption at the top, and below there are two diffusing panels. On the left wall, it's exactly the opposite. Up top we have one diffusing panel, and below there are two sound absorbing panels. This is what's called the principle of asymmetric acoustic design. Look, what's the main rule here? We don't need to have sound absorption here, for example, and directly opposite that sound absorbing panel to eliminate flutter echo. It's enough to have it on one wall. Then in any case, that effect won't occur because as soon as the sound hits here, it will die out with maximum efficiency. And there won't be any back and forth happening here anymore. It has been proven in the same way through multiple listening sessions, multiple projects. I'm currently drawing on the practice of my colleagues from around the world, and this kind of asymmetric placement of acoustic panels is actually much more pleasant to the ear than if we had made everything strictly mirrored on the left and right walls. There's no need to follow this rule 100% of the time. It's not necessary to hang a different type of panel directly opposite on the other wall. In some places, it's perfectly fine to have the same type of panels. There is no need to follow this rule 100% all the time. It's not necessary to hang a different type of panel directly opposite on the other wall. In some places, it's perfectly fine to have the same type of panels. But just in its base, the sound becomes significantly more harmonious and correct. And localization and stereo panorama and everything else, even though it might seem counterintuitive to us. But often it's the counterintuitive things that work much better in practice. We talked about the front part of the room. The front part of the room is basically what's between the first row, or the main row, if you will, and the screen wall. So this is exactly the area. It usually deals with the first reflection. We process it using this principle, two-dimensional diffusers and sound absorption. Let's move on. Here we have the area where the first row will start. Here you can already see that panels of a different type have appeared. These are three-dimensional scattering panels known as 3D diffusers. This panel works in three-dimensional space. When sound hits here, it reflects multiple times and changes direction in different planes. That's why it's called 3D diffuser. This panel works a bit differently. This is what's called a BAT panel, or binary amplitude diffuser. It both absorbs sound and, due to the complex perforation, made according to a special mathematical formula, it also breaks it down at certain frequencies, kind of splitting it up. And it also functions as a diffuser. Here, where we are already sitting, on the left and right walls, it makes sense to start scattering the sound. On these panels, the sound will be hitting more from the later reflections rather than the initial ones, due to the reverberation that exists in the room anyway. And when we scatter it here and further back towards the rear wall, this effect actually works to create a virtual space. So it creates a diffuse field around us, but in the back part of the room, where our hearing doesn't work very well in terms of localization, because that's how nature works, we hear best in this plane and somewhere in front, in the front hemisphere, roughly speaking. So the more diffuse space we create behind us, the more spacious the room we're in will sound and be perceived in the front hemisphere, roughly speaking. So from behind, the more diffuse the space we create, the more large-scale the most important room in which we are at the moment will sound and be perceived. Actually, we don't have the final arrangement of the panels here yet. Some of them are still on their way from production. But in any case, we have a flexible acoustic design system, just like in any project we work on. And it's really important because acoustics is still an empirical science. We always have the opportunity to play around with the so-called 15 of acoustic design. And that's really important because acoustics is still an empirical science. You can't accurately calculate the acoustics of a small room and just set all the panels exactly where they should be and expect to get a predictably perfect result every time. That's why the placement of acoustic panels should be flexible. You should be able to take one down and put up a different type of panel, And here in our showroom, we have that option too. The special mounting system allows us to just take it off the wall like this, peel it off, and hang it back up. Each of the acoustic panels, very convenient and practical. So getting back to the type of panels, so look, the back of the room has significantly more diffusing panels. To be more precise, they prevail here. This type is a three-dimensional panel, base panels, and there are the maximum number of them here. If we look at the back wall, you'll also see three types of acoustic panels there. Here, a slightly different type is used. Here we have what's called a 2D panel, similar to a Schroeder diffuser. They are usually placed in the back part of the room, on the back wall. In many studios, if you've seen what recording studios look like, especially the control rooms, sound engineers often use this type of panel, and even more complex diffractive panels are usually found on the back wall. They work really well here, redistributing the reflections that hit the back wall, breaking them up chaotically in this space, which helps create a sound field that's as even as possible. But you also can't go overboard here. In general, you can overdo it in everything, so you also need to know when to stop. You can't just cover the entire wall with QRD diffusers like these Schroeder diffusers. It's best to make the middle part of the back wall sound absorbing. We don't have the acoustic door here yet. Once it's in place, it will be flat, and we'll put two sound absorbing panels here, completely sound absorbing. This will positively impact the overall sound, to put it briefly. Walls 2D front, 3D back, ceiling next. To summarize briefly, in the front we have two-dimensional diffusion alternating with sound absorption, while in the back part of the room and on the back wall, there are three-dimensional diffusers, sometimes alternating with sound absorption, where the sound absorption is a bit less and the diffusion increases instead. And now let's move on to the ceiling. In the back part of the room, on the ceiling right here, by the way, we can clearly see that we can place a whole bunch of diffusers. Yeah, and I forgot to mention, to sum up, that in the front we have 2D diffusers, cylindrical and polycylindrical, while in the back part of the room we always have three-dimensional diffusers to create an additional virtual space. 2D, 3D, it's all very simple. And on the ceiling, right above the audience area and all the way to the end of the room, that's the diffusion zone. Everything that hits the ceiling should diffuse as much as possible, and there shouldn't be any direct reflections bouncing back to you from there. Sometimes you can alternate it a bit with sound absorption, especially if you have a hard floor like we do here. If the back part of the ceiling should always be maximally diffusive, then the front part of the ceiling, where the first reflection occurs, just like the first part of the floor in front of the screen, should have maximum sound absorption. Basically from the main row to the screen, and from the main row to the screen on the ceiling, it should be as sound absorbing as possible. That doesn't mean you should just cover everything with panels that will absorb sound, but a very important rule to remember is that the area of first reflections on the floor and ceiling in front of the screen should be sound absorbing. You don't need diffusers there. And just to remind you, today we're specifically talking about home theaters and cinema rooms. In music listening rooms, the requirements are a bit different. So basically, there will be less sound absorption, a slightly longer reverberation time, and somewhat different rules for placing sound absorbing and especially sound diffusing panels. Before I talk about the acoustic treatment on the floor, one thing came to mind. This asymmetrical arrangement of diffusers and absorbing panels is actually present even in the standards created by the company Cedia. Right now, on the screens, you can see some screenshots. The CDCEP 22 standard, it clearly shows that they recommend exactly the same thing. So opposite the diffuser on the left wall, we have a sound absorber on the right wall, and the diffusers of different types are placed strictly asymmetrically. So what should we do about the floor? Well, by default, as I've always said in many of my videos, we should have carpet in the home theater. It's both convenient and comfortable, and at the same time, it positively affects the sound, the reverberation time, and the acoustic atmosphere and environment of the flooring. The higher the pile of the carpet, the wider the range of frequencies it will absorb. Actually, the more the better. But if there's too much carpet and if you put too many acoustic panels on the walls and ceiling, the room can also become overly dampened. So, if you have a carpet, you always need to make calculations considering that both your screen wall is completely sound absorbing and the floor is completely sound absorbing. So, in such cases, you should actually place fewer absorbing panels on the walls and ceiling. However, if you decide to go with a hard floor covering, like we're doing here in our new showroom, keep in mind that you should at least put a carpet in front of the screen. Well, for the fans, for the true enthusiasts of proper acoustic treatment, there are special complex engineering solutions that turn your floor in front of the screen into a real proper sound absorber, about 10 centimeters deep. A special niche is created, filled with sound absorbing material, then a mesh is laid on top, and finally, the carpet is installed. This will be even more reasonable and correct because it's important for us to absorb the spectrum of all frequencies that are mainly present in voice and music. There, roughly speaking, from 500 to 4000 Hz. Of course, it's not possible to implement such a solution in a regular apartment, but when we build a home theater from scratch, we've already started incorporating these kinds of things into our projects. I wanted to show the acoustic design plan of our showroom to back up my words. Right now on the screen, you can see the screenshots of the ceiling. The front part is all done with sound absorbing panels. It's not completely covered with them, but there are enough of them, and there's a carpet on the floor too. The carpet has already been bought, it's over there. Of course, it's also black, so that our picture remains as contrasty as possible. But that's a completely different topic. But the acoustic treatment of the first reflection zones, that's probably the most important thing you need to do in the room. And if you don't treat the floor and ceiling, there's a big risk that speech intelligibility will drop significantly, and the stereo panorama will kind of collapse and become a bit murky. Because the reflections from the floor and ceiling, the first ones, can really negatively affect the sound if they're not dampened.
Anton, tell me, how do you figure out how many panels you need to hang?
Great question. Look, the most important thing is not to overdo it, because otherwise we'll deaden the room and it will just end up being a cold space that you'll want to escape from in 5 minutes. Rules. Actually, there are calculations, acoustic calculations. One formula, another. Now some formulas like calculations, as it is usually done, but often we still miss the mark because we live in the real world and we rarely have a very ideal perpendicular room. We don't have a grasp of how finishing materials behave with sound, so all these estimates are approximate. They need to be checked and adjusted. That's why we have removable acoustic panels and we use removable finishing. The basic rule is that if you stick to it, you won't go wrong, and some minor tweaks will be needed to bring everything to perfection. Regarding absorption, you have a carpet on the floor and your screen wall is sound absorbing. Take the total area of the walls and ceiling, subtract about 10-15% from it, and you'll get the area of sound absorbing panels you need to distribute across the walls and ceiling following the strategy I talked about. So, regarding absorption first, if you take into account that you have a carpet on the floor and that your screen wall is completely sound absorbing, then take the total area of the walls and ceiling. Subtract about 10 to 15% from it, and you'll get the area of sound absorbing panels that you need to distribute across the walls and ceiling, roughly following the strategy I talked about today. Accordingly, the screen wall is completely sound absorbing as far as the acoustics technology and so on allow. For all the other surfaces, according to the strategy, you roughly divide them into cubes of 500 by 500 or 600 by 600, and then distribute them in the right order throughout the room. This way, you'll achieve a good effect and a fairly accurate reverberation time for mid and high frequencies, making it comfortable to watch movies, listen to music, or just chat with each other in that space. But if you want to go further and you have the budget for diffusing panels, add 15 to 20%. More area for them. Distribute them similarly throughout the room. This way, you can achieve perfect placement of acoustic panels in your home theater. Distribute them, as discussed, for 100% success with acoustic panels. Sound absorption alone gives about 80% success. In this case, you have a chance to achieve 100% success in correctly and effectively placing acoustic panels on the walls and ceiling of your dedicated home theater or personal cinema. However, even just sound absorption, if you treat a bare room where you used to watch movies with just sound-absorbing panels based on this principle, you'll already get about 80% success. The remaining 20% is all about diffusion. It will create extra comfort and add depth and pleasantness to the acoustic atmosphere. And what about low frequencies? Just ask me. Yeah, these panels really work on mid and high frequencies. Because for a panel to start working at significantly lower frequencies, it becomes much more complex structurally and really needs to be a different type altogether. We discussed how to deal with low frequencies, how to absorb excess bass, and how to create a smooth, rich bass in your home theater in a whole series of separate videos on our channel. If you haven't seen them yet, I highly recommend you check out the links in the description and watch them all. You won't find this kind of material anywhere else on the Russian internet. Give us a thumbs up if you finally got answers to your questions about acoustic design in your home theater. It would be great, friends, if you could write in the comments what new and useful things you learned from this video. Don't forget to subscribe to our channel, because only here will you find the whole truth about everything related to real home theaters and cinema rooms. Well, this was Anton, the founder of Blackroom. May the right acoustic design be with you. See you in the new videos.